Right, so welcome everybody that's joined us. We possibly will have some more joining us as we go, which is fine. My name's Paula. I'm the chair of Engineering Together, and I'm going to be chairing today's Sustainably Engineering Together session. So give us a thumbs up, Phil, if you can see the slide.
Yes, we're all right.
Perfect, yeah. Right. So it's been recording and stuff now. But Tim, you've got your hand up. Was that an okay? Yeah, fantastic. Right, so I'll start from now properly. Okay.
The production, looking at TRISO, fuels, etc. The top right-hand corner, research and development. I put that there for interest because the Netherlands is just going ahead with a new reactor, a place called Patents, which is just to produce isotopes for the medical industry. Left, decommissioning and waste. There's always activity there. The left-hand picture is perhaps difficult to make out, but that's of a 300 cube waste box, and that's important because this is starting to be illustrative of what happens in the northeast. So that box is made by Darkham Engineering, and the last I heard there was something like 40,000 of those boxes required. Adjacent to that is the geological disposal facility. We don't know where that will be, but it'll probably be based in Cumbria. That's some years off, but there'll be a huge amount of engineering work required with that. In the centre, defence. Well, that's all about AWE at Aldermaston and the submarines. AWE, they have projects on the go to upgrade their systems. Defence, that's been bolstered recently by the new AUKUS contracts. So lots happening there. Existing generation, well, that unfortunately is where it's going to boil down in a couple of years to just size will be. Then bottom left-hand corner, fusion. You may be interested to know there are over 50, well, I think 50 private fusion companies. And there's a huge amount of funding going on globally into fusion. And in the UK, we've got two companies, Tokamak Energy and First Light. And the pictures there, one is the ITER project, which is happening in the south of France. And that's important for the northeast because our system at Sunderland have been heavily involved with that project. When we move to the right in new build, then we have obviously Hinkley going ahead. We hope that Rolls-Royce will get an order for their small modular reactor somewhere. And on the right, I've added the STEP project, which is a fusion project, which has just been launched recently. So that's going to be based at West Burton in the Midlands there. So you should get from that, if you weren't aware already, there's quite a lot happening. And that's before we've really touched upon small modular reactors. Thank you. So what are SMRs? Well, the fundamental is that they are smaller. And in fact, some are not so small, so but others are tiny. The key element, of course, is the modular, but there are different approaches. Some are big modules, some are transportable modules, different approaches. Because of the modularization, they're quicker to build, and perhaps more importantly is this greater security of program. And we will look at the situation where, because things are being made in the factory, that we know exactly when they're made and they're put to site on time. And just put the note there are regulations which need to be adhered to, of course, and it takes time for companies to go through the process. The modular approach does mean that there's more factory construction. In fact, in the ideal world, then all of the construction would take place in the factory. That gives far greater control. That's better as I say, from a cost perspective, from a project control perspective, and also from a nuclear safety perspective. What's interesting in terms of small modular reactors is they can now be flexible in operation and they can offer high temperature heat. So we'll talk more about that. Thanks. So we'll talk about some possible small modular reactors for the UK. These 6 were on the shortlist for Great British Nuclear. Only 5 of them have recently submitted bids, and we should know before the end of the year as to which of those has been successful. Probably 2 will be successful. So we have Rolls-Royce with their SMR. They have done an awful lot of work. They have been steadfast in their approach. They've got, I think, about 750 people working on the project at the moment. They desperately need an order to maintain their momentum. But I think very importantly, they've recognised just how much effort needs to go in to do all the work that's necessary to design for modularization. The next one along, EDF Newark, is the one that they haven't put in a bid, but really they are not too bothered about that because they can always enter the race later. GE Hitachi, they've found success. I think the most likely place for them is Canada for their first plant. Then we move down to Holtec. I don't know whether people will be familiar with the name Holtec, but Holtec is important because as we go through, I'll start to talk about the runners as well as the riders as well as the runners, because there is a race here, and the Holtec is owned by a gentleman called Chris Singh, and I've been fortunate to have seen his company grow over the last 25 years. He's an engineer, and he has now built a company which has got the ability to make everything that's required for a new nuclear plant. He has got 2 sites, I think, in the States. He's able to build a plant in the United States. He's got the site. He can do everything. He's vertically integrated, and he's a very focused man. NuScale Voyager in the centre. They've been around for some while now, and they are approved in the US, and they aren't seeing as much success as they would have liked, but they are seeing success in Europe as well as the States. The Westinghouse AP300 we'll talk about later because it features. So we'll move on to the next slide if you don't mind, Paula. Thank you. So we've seen 6 possibilities. Well, here's another 6 possibilities. And in the overall picture, there's lots more throughout the world. The top left is a molten salt reactor. Now you can see this is only 30 megawatts, but this is, as the name implies, able to load follow. So the idea with this particular reactor is that it complements renewables. They are having most success in Canada. I'll talk about Canada later. We then move on to the new Clio. Now this is a lead-cooled fast reactor, 200 megawatts, and I will say something more about that later because that could feature in the Northeast. Then I've talked about the riders as well as the runners. So we have TerraPower. That is effectively Bill Gates' company, and you won't be surprised to hear that in addition to the $2 billion that the US government is providing, he's he's got investors to the tune of $2 billion at least. And they have just this last week broken ground in Wyoming to start their first plant. Bottom left, penultimate power. Well, I'll talk a little bit more about them because they feature in the Northeast, but they are a Northeastern company based in Newcastle. The Last Energy, now again, this is a smaller one, but the PWR20 is a small reactor, but they will provide, as you can see, I hope by the photograph, they'll provide several units to make up whatever power you want. Then bottom right, X Energy, and I'll say more about them because they could be at Hartlepool. So we'll move on to the next slide if you don't mind. Now, I don't know whether many people are aware that there's also what are called micro reactors. These first initiated in the US by the military, who recognized that they had a lot of generators, diesel generators, which they used for their facilities wherever they needed a McDonald's or whatever. And they had a competition, BWXT, who build the reactors for the nuclear submarines and aircraft carriers in the States, won the contract. And these are looking at something like 1 to 5 and perhaps 7 megawatts. But you can see how much smaller they are. You can see there's X Energy over in the States and looking at potential container. But that's an interesting area. Ultra safe. I've had some grants from the UK government, and so they could feature somehow, but we don't know yet. Next, please, Paula. So, most importantly, what SMRs could there be in the Northeast? At Hartlepool, we have got a very enthusiastic company, X Energy. Now, as you probably saw before, they have blocks of, and they have each block will comprise 4 reactors, and they aim to put 3 on the site at Hartlepool Nuclear Power Station. They've been successful in getting some money from the Future Enabling Fund, and it's a 50-50 situation. The government puts in 3.3 million, and they put in 3.3 million. But you can see from that they are on with that, and they've got certain targets to achieve. Hartlepool would be their second installation after Dow in Texas. I'll mention that later. They already have partnerships in the UK with Cavendish Nuclear, Kia, Sheffield Ford Matches, and the Nuclear Advanced Manufacturing Research Centre. And perhaps of interest to some people would be that they are aiming to have a supply chain event in October. Also, on the right-hand side is Penultimate Power, who would also like to build a nuclear power plant at Hartlepool. They are a much quieter organisation, but they have been around for at least 10 years, and they have Japanese technology. The Japanese are very keen, and I understand they're in discussions with the government. Next, please. And there are possibilities for other SMRs in the Northeast. In particular, Cowpanguli, there's Community Nuclear Power, CNP. They are very keen. Now, their approach is different. So they are wanting to be a provider of energy. They are saying that they will be providing mainly steam as opposed to electricity. They will just have a light connection to the grid. Their aim is to work with a group of companies in the very local to them, and they will supply energy. CNP is based in Cumbria, and it's headed by Paul Foster, who's the ex-CEO of Sellafield. So again, he's a man who knows his way around the nuclear industry. They have already applied for what's called a development consent order, which is the first stage really in moving forward. And the AP300, which is the Westinghouse, is a derivative of the successful AP1000, which is operating both in China and the US. Elsewhere on Teesside, there is another possibility, and this is the company, the lead-cooled nuclear reactor. They have an Italian lead. Again, he's a strong personality. Now, although it's Italian, they are actually headquartered in the UK with an office at Manchester. They have plans for 20 throughout the UK, and they have said that Teesside is an attractive area for them. No decisions, but it's attractive to them. They're partnered with that system we mentioned before, and they have an MOU with Nuclear Advanced Manufacturing Research Centre. And perhaps interesting, Nuclear have an agreement with Viaro Energy. I don't know them, but apparently they're an offshore company, offshore oil company. So I don't really understand how that works. But as you can see from that, so in terms of the region of the UK with most possibilities, the Northeast has the most possibilities for small modular reactors. Next, please. And along with the small modular reactors, there are possibilities of factories for assembling the modules. Rolls-Royce have said that they've got 3 possible locations, and 2 of those locations are Sunderland and Teesside. Obviously, this all depends upon them getting an order. Then we have X Energy, and they have indicated they too would have a facility on Teesside if they were successful. And Penultimate Power also have said they will build an SMRs factory in the Northeast if they're successful. And then we have Holtec. Now, Holtec have aims for building nuclear power plants in the UK. We don't know where, but they have said that Teesside is one of 4 possible sites for an SMR factory. Again, depending on them being successful in the UK. Next, please. So we've had nuclear power for a long time. Why are SMRs now attractive? What makes them so different? Well, the first is low-cost, secure sovereign power. They will provide low-cost power, and when we see that there was sometimes last week, I think it was, when 20% of our electricity was imported, then I think there is a strong case for more sovereign power. High temperature heat has become more important as we try to tackle some of the aspects of the industry challenges with achieving net zero. There are a lot of processes in the industry which require high temperature heat, and some of the nuclear plant that we've talked about can actually achieve 780 degrees centigrade. So this is going to be really a vital part of our achieving net zero. Along with that, with this ability to supply the high temperature heat, the energy, then we've got potential to produce hydrogen and synthetic fuels, much as CNP, I think, would want to be producing on Teesside, not producing, but supplying the energy for. Desalination, this is not going to feature in the UK, but other parts of the world, as part of climate change, are seeing long-term droughts. Morocco, I think, has had a 9-year drought, and you can see that that will be an option for countries which are struggling with water supply. Off-grid power. In Canada, they have a lot of requirements for off-grid power. Not surprisingly, they don't have an extensive grid as we do. So they've been long interested in small modular reactors. So if you've got a large town somewhere, a small modular reactor is ideal because if you think about it, it's not the ideal place for really for wind or solar with the winds they get. District heating, this is featuring more highly, but district heating has been associated with one or two nuclear plants throughout the world. Dedicated power sources. Now, this is most probably applicable to data centers. Data centers require something like 20 to 40 megawatts. And the introduction of AI means that will increase to perhaps 80 megawatts. They say there's going to be a doubling of the need for data centers, and with them the power sources for them. And it makes sense that you can have your own nuclear power plant, which is 24/7 dedicated to you having the necessary essential electrical power to your facility. Flexible load following, mentioned Multex Flex, but they're not the only ones. And this is going to be important. We've got a high proportion of our energy which is being provided by renewables. Then we know full well sometimes the wind doesn't blow, the sun doesn't shine, so they're ideal for just ramping up the power whenever you need them. And then the other one is the mobile power, which are referred to with the BWXT word, the Helen. Thanks, Paul. So here's the big question: when will they be deployed? Well, this is a race. It might not appear to be a race, but I mean, in the background, the US government is giving grants to, or helping financially, all of their nuclear power providers in their export drives. But in the UK, the Rolls-Royce SMR is progressing. They have just completed their second phase of the generic design assessment, which is great, and they will continue fluidly into the third phase. That should be completed 2027. Their final investment decision, I think, is 2029, I think, and it'll be the early 30s that they're in for. TerraPower, Bill Gates' company, is aiming for the end of the decade in Wyoming, and as I say, they've started work on the site. X-Energy is in partnership with Dow Chemicals, and they're aiming for nuclear plant to be up and running in Texas by the end of the decade. GE Hitachi, they're looking to the end of the decade in Canada. Last Energy, mentioned them, they're aiming for having a nuclear power plant up in 2025 in the States. BWXT are on track for 2025. And there's other companies which at the moment don't have plans, but this last week, then Kairos in the States have successfully gone through the nuclear safety review by the NRC. And what was interesting about that was not just that they've been through it to enable them to achieve their 2027 completion date for 2 35 megawatt reactors. What was interesting was the effort that the NRC had put in to pull that forward 4 months. So there's effort all round to accelerate the approval of the nuclear power plant in the States. So back to the UK, X-Energy and CNP could start on site about 2030. That's their aim. And Rolls-Royce SMR factory, well, we don't know, perhaps a couple of years yet. Thanks, Paula. So I make a statement: SMRs will be successful. And that's because the burst start, it's not just about power. The compact, CMP like to say that the Westinghouse AP300 nuclear island would sit in the penalty area of a football pitch. But some of them are tiny, not quite able to fit on your drive, but certainly there's sort of a couple of transport containers, the smallest one. Global, globally, we need to achieve net zero, no doubt about it. There will be large numbers required. Bill Gates is targeting former or existing coal plants. There's 254 sites he's identified in the States where his reactor could be used. So you can see that's giving you some idea of numbers. There are 5,000 data centers in the US, and well, they're going to require another 5,000. I don't know, but you can see we'll talk about large numbers. From a cost perspective and from a delivery on time perspective, we're going to move from a construction project, which has got all its risks, to a factory product. In other words, you'll get certainty of both cost and delivery. And with the numbers, well, the economics of volume will surpass the economics of scale. So you won't be wanting a giga plant like Hinkley anymore. You'll want to have several small modular reactors because they will be less costly. And if you think about it, the speed at which some of these plants can be built, the last energy are talking about 2 years. Now you can imagine if they get their plant up and running in 2025, then they start into production because they say they've got a pipeline of 65 reactors in Europe. You can see that they will improve rapidly. By the time that Hinkley is completed, they probably will have had several years of operational success and manufacturing success. And over the top of all this, we've got digitalization, and that will just help with everything, particularly cost reduction and enhancing nuclear safety. Anyway, I think I've probably said enough. So that's some contact details. And I would encourage you to become a member of the Nuclear Institute. It doesn't cost very much. And we're over to questions.
Excellent. So Laura's going to take over. So Laura.
Thanks, Paula. Hi, everyone. I'm Laura Brown. I'm the co-chair of the Women's Engineering Society Tiny T's cluster, and I'm helping facilitate the questions to Phil today. So if anyone's got any questions, you put them in the chat. First of all, type them in there. That's perfect, as it'll help us manage them in a timely manner. There's a couple of questions just round about the logistics. Phil, and a question if they could get the slide pack, if you'd be happy to share the slide pack with the attendees today.
Yeah, that's fine.
That's great, thank you. There would there's a question from Julie and Julie Harrison. So the question is, there was discussion a while back about nuclear waste being placed under the sea at Hartlepool. Is this still a possibility? Have you any insight to the waste element of the nuclear industry?
I don't have any particular insight, Julie, but my understanding is that the main contenders for nuclear waste are not in the northeast. So the sites for the GDF, the Geological Disposal Facility, I think are most likely in Cumbria.
Cumbria, okay. A question from Mark Lewis on what are the Chinese doing in this area? If you've got any knowledge of that.
You won't be surprised to know that the Chinese do have their own small modular reactor. And just as background, then the most successful in terms of export are the Russians, and they have their small modular reactor program. In fact, they have a nuclear power plant on a big barge, effectively, which they can tow about. And there's the Koreans. We should mention the Koreans as well. The Koreans have got their development of small modular reactors, and they too have the idea to put them on the barge as well. So there's a lot of happening. I couldn't possibly cover everything happening, but that gives you an indication of what's going on. And yes, the Chinese have exported, and they will press to export, and the Russians will export as well.
Thanks for that. Paul is asking that historically cooling water had been required. So she's saying that that's the reason that nuclear power stations have been historically sited at coastal locations. So the question is, how are these units cooled?
Well, I think it's the same, but I can't say that I know. And again, I've got to say that we've got such a diversity of nuclear reactor types now, because I mentioned molten lead and molten sodium. So I don't honestly know what is the cooling for all of these, but I mean, they certainly, I read somewhere that the new plant are destined for, I think it's Poland, they've got permission for the river temperature to be, for the water to go back into the river at a higher temperature.
Mhm.
So yeah, so yes, that is a challenge.
Yeah, it's just most thermal power stations have that challenge, don't they?
Yes.
So next question is from Daniel Tyrrell. How will the fleet be regulated? Are the ONR ready for a significant rise in new sites and locations? It's a great question. Are the
That's
regulators
a great question.
ready?
I honestly cannot answer that one. I would hope so. I mean, I think I personally was quite alarmed to see this article that was saying how the company Kairos had got their approvals through from the US point of view 4 months early, and that the ONR have accelerated their processes, and but you know, there's an awful lot of work for them, as Daniel says, in terms of, you know, we've got so many different reactor types. Yeah, it's going to be a challenge for them.
Yeah, it's a good question, Daniel. I've got a question from Amy Boyd. Is setup time the main advantage of small modular reactors versus the larger ones? So is it construction time?
I think it's the program certainty, along with ensuring that if you know anything about construction sites, and you see any large construction site, never mind nuclear, all the risk is at the construction site. And the site at Hinkley is huge. I visited the Flamanville construction site over in France, which is the same reactor. And it's so big, it takes you 20 minutes to walk from where your offices are to the actual nuclear area. They're huge, and with that goes all the logistics, because anyway, there's a huge amount of risk there, and that's where the cost risk is. Whereas if you're making things in the factory, then you know when they're going to be ready, and you can deliver to site on time.
So there's a safety aspect as well as the sort of on-site assembly benefit. Is that
definitely the I mean, the the fewer people you have on a construction site, the better. Okay. And the fewer operations you have on site, the better. So the main thing that you'll have in modules is the lifting, which is to be expected, but there will be fewer lifts because you're just lifting. In the case of Rolls-Royce, they've got 800 modules, I believe, so they would be lifting 800 modules into position, and then you've got the connection. So it's a far simpler operation on site.
Okay, thank you. Tim Sotens is asking, how does distribution of nuclear power plants scale requirements for safety, security, and radiological safety functions?
I don't really know how to answer that one, to be quite honest. I mean, they from a nuclear safety point of view, then the case has to be made for each individual nuclear power plant. So I think that's the answer to that one.
Okay, thank you. And Mary is asking, or sorry, Sadhana Mary is asking, are there SMRs operational in progress in the UK? And are there SMRs operational in the UK or other parts of the world?
No, there's no operational plants in the UK. The first most likely one is going to be the Rolls-Royce, or perhaps the X Energy, or perhaps even the CMP. They're the most likely at the moment, and they're not till the 2030s. But there is a lot of activity in preparation. There's a lot of people engaged with SMRs in the UK, and there are SMRs operational in Russia. And I think the Chinese, trying to remember, the Chinese may have just become operational, but they're not far off, of course. Yeah.
Okay, great. Paula's asked the question, I'd love for the industry to work with local bodies to make use of the warmer water into heating systems or industrial processes. Is there any talk of this? Actually, I think you've noted it in one of your projects.
Yes, that's right. District heating, but there's other possibilities as well. It becomes quite complex because the data centers use their heat because they produce their heat from their electricity. They're used for greenhouse heating. But yes, there has been talk. Certainly, CNP, Community Nuclear Power, are very keen to enter into discussions as to district heating and other industrial low temperature heating for all this, all this heat that's available. Yes.
Right. And Paula's added a spin on the question. Can you ever see a time when these are available small enough for streets or small communities?
I don't think so. I think the military will have access to the smaller ones, and I think that we're not going to be in a position where we can hire one from B&Q and from the bottom of the street instead. But the military will, I'm sure, utilise them.
That'd be interesting. Picking up at B&Q. Yeah, thanks for that. I've got a question, if you don't mind. Looking at some of your diagrams, particularly the ones that show sort of little hedgehog-like lumps over, make me think of just the one of the benefits of modularity might be that you can switch some off while the others are on. Now, I'm from the power network company, Northern Power Grid. So for us, the demand for power is obviously very time dependent. So, for example, in the UK, we need, and even on the worst day, we need almost double the power we need at 5 p.m. than we do at 5 a.m. So, that ability to deal with those variations through the day is very important. Do you think is that one of the elements or one of the benefits of having smaller modular units altogether, that you can, sort of change your demand rather than just having a large
Yes, this is with the smaller ones. So they range in terms of the small modular reactors from being 20, 35 sort of megawatts, 70 megawatts perhaps, up to 470 megawatts, which is the Rolls-Royce. But the smaller ones, you take the Multex Flex. Yes, they can vary their power and they can just keep switching them on very quickly now, apparently. So, as I mentioned in the presentation, with renewables and with your, as you say, your power requirements, then you can just switch them on. And I think very good. How quick, I don't know, Laura, but I mean that's what they're saying they can do. And you can see that you can. If you've got banks of 20 megawatt, and just click them on one after the other.
Yeah, that agility will be really helpful, I think, in making the business case for them. Because one of the big challenges of the big moths of the nuclear power is once it's on, don't ask them to switch it off. It's on until you've got that power whether you want it or not. So yeah, hence we've got so many interconnectors with France to take all their excess nuclear power. That's great, thank you. There's some more questions in the chat. Would it be possible to repurpose existing thermal plants with SMRs? It's a good question. That's from Afuri.
This is what I mentioned, is that this seems to be, well, it's a focus not just for TerraPower, the Bill Gates company, but for others who are looking at the applications of small modular reactors. It's a different world now with small modular reactors. That perhaps didn't make it clear now that with the wide breadth of applications that are, then the vendors are sort of targeting which is their best area. So, as I mentioned, the Bill Gates has identified, not him personally, his company's identified 254 coal-powered plants in the States where they could replace it. And the benefit they have, of course, is that all the connectivity is there. As from your point of view, you don't have to build anything more there, how much it utilised the existing power generation, but I don't know. But these are all the factors which make it a better case for the small modular reactors. So
Yeah,
yes,
it's a great,
definitely.
it's great to reutilize those assets, as you certainly those grid assets, as you mentioned.
Yeah.
Paula is asking, when we say low cost, estimate of how many SMRs for one Hinkley Point cost once they're in full production?
I don't know the answer
Yeah.
to that question, but what I can say is that when we look at the smaller modular reactors, then, and I was trying to say this, that when you've got a last energy that says that they can build a nuclear power plant in 2 years, and they're not just talking about one unit of 20 megawatts, they're talking about several. So you have to start to think about what that means in terms of the manufacture. So say you wanted to have one which comprised perhaps 20 of these 20 megawatt units. Then when you're starting to get into manufacture, by the time you've made the 20th, you can see that you will already be reducing costs because you're starting to learn how to make them and be making them better, so that their costs will reduce more quickly. So I think that some people have made the comparison with aircraft, and I think it's a valid point, is the way that these will be made, the smaller ones will be comparable with an aircraft, and you'll get the costs down. And so, yes, how much will the cost vary? I think, it's going to depend upon the SMR, it's going to depend upon the size of the SMR and how well their production is.
Yeah, and ultimately how efficient they are at producing power, really, because that's how they're going to get their profit, isn't it? It's how much money they can make from the outputs from it.
Yes.
Julie's got a question. BP are building or proposing to build a gas plant on Teesside. Would SMRs negate the need for another gas plant?
Well, personally, I would hope so. I mean, I can't answer that question. My personal belief is that yes, it would. The challenge is the timing, is that they can build a gas plant in no time, and so they've got a need for power now. But in 5, 6, 7 years time, and hopefully we'll get SMRs, and switch the gas plant off.
Yeah. And Mark Lewis has got a question. Is the fuel sourced from friendly states? So this is more about the fuel for the SMRs.
The fuel is dependent upon the type of small modular reactor, but yes, in the fuel, basically the uranium, but they're not all powered by uranium. But we won't get into that now. But they certainly that is a key question, and that's not a problem.
Okay, you heard it here first.
Yes.
Okay, so I'm getting a big message from Paula here that I can hand back to her.
Right.
What if the questions are exhausted?
Okay, so I'll make a last call out. Has anyone got any final questions that they'd like to put to Phil when we've got him on the spot here? Oh, Sally's typing. I love how Teams lets you see who's thinking about typing.
So we. Oh, no, that's fine. It's somebody.
All right.
So everyone's safe. If there's any more questions, which is great. So handing over to me then. So I'd just like to say thanks, obviously, to Laura for helping with the event coordination, but definitely thanks to Phil. I've personally found it, the opportunity that this presents in terms of getting us to net zero, I think is pretty enormous. There's obviously been lots of work done behind the scenes to get to where we are, and I'm pleased to know that much of it is in our own backyard, you know, and obviously local companies are involved in this as well. So I find that very, very interesting. That obviously everybody else has found it interesting as well. As some messages coming in, and we've had plenty of questions, and a wide variety of questions, which is really, really good. And yet we continue to have things coming in. So just a reminder, this will be onto the Engineering Together YouTube. I will share it with everybody. Phil said we can have a copy of the slides as well, so I'll sort that out. And we don't currently have any events to advertise for Engineering Together or WES, Tyne and Tees. I'm not aware of any from the Nuclear Institute, Phil, but all of the websites have all of them details on, and definitely sign up, and then you'll get notifications. So yeah, so lots of lovely comments coming in about thanks for the insight and range of possibilities, and what a great presentation. So I'll just say thank you very much, Phil, and thanks to everybody for joining, and hopefully we'll see you on another Engineering Together event before we know it. Thanks everyone.
Cheers. Bye.